Alright, so now we're getting ready to look at a more complicated complex fraction. I'm going to show you method 1 first, and then I'll show you a method 2. Our instructions are to simplify 1 over a plus 1 over b divided by b over 2a minus a over 2b. In my method 1, I'm going to take the numerator and I'm going to go off on, the side of my paper or scrap paper or something like that. And I'm going to deal with this numerator all by itself. So I know that to accomplish this addition of two fractions, I need a common denominator. I don't have to go through the whole LCD chart process because it's very simple. I know I'm going to need b over b times the first fraction, and I'm going to need a over a times the second fraction. And when I work this out, I'll end up with b plus a over a times b. Now, oops, sorry about that. It gets away from me sometimes. Now I'll work on the second fraction. So I have b over 2a minus a over 2b. And I have a similar problem, but here I can use the idea of least common denominators. If I inspect these two denominators, I see that I have a 2, I have an a, I have another 2, I have a b. So I have 2's in both denominators. What I don't have in both denominators are the variables. So I'll use b over b times b over 2a. Then I'll use a over a times a over 2b, and this will end up being b squared minus a squared, all divided by 2ab. Now I notice something here. I have that difference of two squares pattern, so I can actually take this one step further to b minus a over b plus a, and it's all over 2ab. Now when I replace these in the original expression, to save space, I'm going to put them in up here. I'm going to have b plus a over ab for the first one. There's my heavy line, my heavy dividing line. In the denominator, I'll have b minus a, b plus a, all divided by 2ab. From here, I'm going to do a little bit of erasing. Alright, from here, I can rewrite this as b plus a over ab divided by b minus a times b plus a divided by 2ab. Now this is a good place to stop and say, what are the restrictions on these variables? Essentially, a is not allowed to equal 0, b is not allowed to equal 0, and now I can go through my next part of the process. b plus a stays, there's my keep, there's my change, and here's another change. Like that. And since I've already declared what my variables can't be, I'm safe to start crossing things out like this. I have a b plus a here and a b plus a there. I have an a and a b and an a and a b. So my answer, including the restrictions, is going to be 2 over b minus a. And that's it. So that looks a whole lot nicer than what we started with.